So once again, welcome to the next live sessions video of physics. And last class we have discussed till question number 27. Today we are going to discuss from question number 28. Let's read the question. A capacitor of capacity 4 microfarad is charged to 80 volt and another capacitor of capacity 6 microfarad is charged to 30 volt. When they are connected, the energy lost by 4 microfarad capacitor is what? Okay, so initially 4 microfarad capacitor, which is charged to how much is the voltage which is given there? 4 microfarad capacitor is how much? 80 volt. Another capacitor 6 microfarad is charged to 30 volt. Now the question is given, when they are connected, the energy lost by 4 microfarad. This is what we need to find out. Okay, so 4 microfarad connected to 80 volt. What is the energy in the 4 microfarad capacitor? So how we can write? So we can write energy in the 4 microfarad capacitor. Energy in the 4 microfarad capacitor is equal to, how we'll find out the energy? Half CV square. This is the energy of the capacitor. And this much energy is stored in the capacitor. Now we'll substitute the values to this one. So we will answer this one. 1 by 2 into C is how much? 4 microfarad. So 4 into 10 power minus 6 into V square. V square means what? 80 the whole square. Correct. So once we solve it, how much we'll get? This 2 will get cancels, and 8 into 8 64, 64 into 2 128. So it becomes 0.0128. Energy, the unit is called what? Joule. So we'll get 0.128 joule. Will get the answer. Okay. Now what is they have given? This is the initial energy which is stored in the 4 microfarad capacitor. Now question is asking, when they are connected together, what is the energy loss? Okay, so now this is the initial energy of the capacitor. I can say this is the initial energy held by the capacitor. So this is the initial energy. This is the initial energy held by which capacitor? Held by the 4 microfarad capacitor. This is the initial energy which is available on the capacitor. Now this capacitor is connected with which capacitor? Now the capacitor is connected with which one? The capacitor is connected with 4 microfarad capacitor. Okay, so now we have the 2 capacitors will be there. One is a 4 microfarad capacitor and one is a 6 microfarad capacitor. So what is the voltage on the 4 microfarad capacitor when they are connected together? 4 microfarad capacitor initially is holding how much is the voltage? 80 volt. Now 4 microfarad 6 microfarad they connected together. What will be the final potential on the 4 microfarad capacitor after the connection? How to find out this one? So I can say potentials on the 4 microfarad capacitor when after connection with which capacitor? 6 microfarad capacitor. After connection with the 6 microfarad capacitor, how to find out the voltage? Voltage V for 4 microfarad after the connection is equal to how will find C1 V1 plus C2 V2 divided by C1 plus C2. Idana 4 microfarad capacitor voltage. So what is C1 will be there? 4 microfarad capacitor. So numerator microfarad verum, denominator microfarad verum. So both will get cancelled. Okay. So 4 into 10 power minus 6 it is not required because both numerator denominator capacitor 10 power minus 6 will come, both will get cancelled. So 4 into V1 is 80 plus what is C2? C2 is 6. What is the voltage across C2? It is 30 volt. It's given in the question. So it is 30 divided by C1 plus C2. What is C1 plus C2? 4 plus 6. But this how much will come? 320, 6 into 30, 180 divided by 10, 500 divided by 10, which will be equal to 50 volt. Yes?
Excuse me, sir.
Tell me.
Sir, Narthana is in meeting room. Narthana is in meeting room, sir. Can you admit her?
Okay. She is still there. Huh? Okay. Two people are there. Okay. Done. Thanks. Okay. So now the volt initially 4 microfarad capacitor will have how much voltage? 80 volt. Now the 4 microfarad capacitor will have how much is the voltage? 50 volt. So initial energy we calculated 0.0128 joule, that is based on 80 volt. Now we are going to calculate. Now I know 4 microfarad capacitor will have 50 voltage when they are connected with the 6 microfarad capacitor. It is not 80 volt. 80 another reduced to 50 volt. Now I'm going to find out what will be the final energy. Final energy means after the connection. So the final energy, how to calculate the final energy of what? Final energy of 4 microfarad capacitor is equal to how much will come? 1 by 2 into again CV square. But 1 by 2, C is how much? C is how much is coming? 1 by 2 into C is again it's the same capacitor, right? 4 into 10 power minus 6 into V square. But what is the voltage now? It become 50 whole square. Now the voltage is dropped from 80 to 50. We have seen, right? This the value of the voltage, which is initially will be there 80, and now it is dropped to how much value? Dropped to 50 voltage. Okay. So we'll solve this one and we'll get how much will be there, and 2 cancel. So 10 and 5, 25 value. 25 divided by 2, 12.5, again 0. So 0.005 joule. This is the final energy. So now how we will, what is the question they are asking to us? Energy lost by 4 microfarad capacitor. What is the energy loss? So energy loss means how much, how we will calculate? Initial energy minus final energy. So initial energy we already got 0.0128. Final value we got 0.005. Now we will calculate the energy loss. So energy loss equal to initial energy. Energy U normally represent in the minus final energy. Energy. After some incident, our energy will be lost. Correct? Morning we will take breakfast, so we have good energy. Then we will study something, we'll go to school and we'll do certain activities. Then our energy will be dropping. So initially we'll have highest energy. So which means that what is the initial energy? 0.0128 minus final energy 0.005. Simplify then how much will come? 0.1285234 0.078, otherwise 7.8 millijoule we can write. I don't know how it is given in the answer, but it is 7.8, 0.078 7.8 millijoule. Another answer. In the difference 0.0128 minus 0.005. Let's have a look into the answer. Yeah, it's there. Option number 1. Option number 1 is the right answer for the question. Is this clear? Okay. So as a summary, what is included in the question? First, the question is speaking about you have given a 4 microfarad capacitor. So 4 microfarad capacitor, which means we have a 4 microfarad capacitor, which is connected with a voltage. So this is a 4 microfarad capacitor connected with 80 volt. This is the initial situation. Then there is a transformation. After the transformations, what will happen? Now what is the final conditions over will be here? What is the final state will be there? Now it is like a 4 microfarad capacitor is connected to what capacitor? Another capacitor. Now we have become 4 microfarad and 6 microfarad. Okay, when they are connected together, they connected. Initially 4 microfarad, the voltage is how much? It is become 80 volt. 6 microfarad will become 30 volt initially. But after the connection, there are some charge transfer will happen. If charge transfer will happen, then its voltage will be changes to how much it become? It changes to 50 volt. Oh, sorry. Okay. Sorry. Okay. Okay. So it changes to 50 volt, and based on the 50 volt, we have calculated the new energies which are there, and these new energy which are equal to 0.005, and we are finding the difference of energy. So answer will become equal to 7.8 millijoule. Is this is clear to all of you? No? Yes. Yes or no? Silence, take it as yes. I'll go to the next one. Question number 29. Okay, what is given in the question number 29? Capacity of a parallel plate capacitor is 5 microfarad. So one capacitor value is given, which is equal to 5 microfarad. When a glass plate is placed between the plates of the conductor, its potential become 1/8. So initially the capacitor structure is like this. This is the initial capacitor structure. So whose value will be equal to how much? 4 microfarad. Now what will happen? Now the situation changes in the sense how the situations will become now. Now ide plates of the capacitor, but what is the point will be there in between the plates of the capacitor? What we have placed a conductor. So if you have placed some kind of a metal in between the plates of the capacitor, question is given, potential become 1/8. Potential become, so initially V in the voltage, now the voltage is drops to how much will be there? It become V/8, 1/8 IT voltage drop it. The value of the dielectric constant. The value of the dielectric constant. Value of the dielectric constant means the potential drop. I can say the new value of the potential. Say let's take an as V dash. So I'm saying V dash will be equal to V/8. Dielectric, so another conductor, something is placed in between the capacitor and its voltages will be reducing in the sense like V dash will be equal to V by the dielectric constant. This many times this will be reduces. In the theory lesson, we have mentioned this concept. So based on this, we will write, so V dash is equal to V divided by 8. We got. So this is equal to V by dielectric constant K. So in this case, what is the value of dielectric constant? Dielectric constant equal to K. Okay. K means which is the value equal to 8. So answer will be equal to 3. Is it clear? Tell me, yeah, yes or no. No, nothing, no reaction. First year students are very better. You are very weak, huh? Second year students. First year students will be at least say yes, sir. Yeah. Okay. Okay, let's move to the next one. 30th one. Okay. Now, what is the 30th question is speaking about? Placed on the insulator stands sphere of radius R1 and R2 having the charge. Two spheres will be there. One is having R1. So let's have two spheres. One sphere is the sphere which having the radius of R1. So which having the radius of R1. And let's have another sphere and which have a radius of how much will be there? R2. Now these two spheres having a charges of how much will be there? Q1 and Q2 respectively are connected to each other. Then question is asking, Here question is not placed two spheres. Okay, so 2 is missing over will be here 2. So 2 spheres on the insulated stanza, sphere of radius r1 and r2. Okay, so we know now 2 spheres will be there. One is having the radius r1, another one is having the radius r2. Both are carrying the charges of q1 and q2. Now what will be the question? So based on this, there is, which of the following statement is true will be here? No change in the energy of the system. Definitely energy of the system will be changes. So first statement is a wrong statement. Why we are saying there is no energy in the system? Capacitance of a sphere equal to 4 pi epsilon 0 times of r. When radius changes, energy we are calculating based on half cv square. So when capacitors will be changing, because r1 and r2 changing, energy will also is a varying quantity. So energy will be varying. That's what first statement is not correct. Second one, an increase in the energy of the system. I cannot say energy is increased or energy is decreased. It's all depends upon the radius. If radius increases, it will increases. If radius decreases, it will decrease. So second statement is a wrong one. Third one, always decrease the energy of the system. The same story again. I don't know whether it will increases or it will decreases. It is depends upon the radius of the sphere. Radius changes, capacitance will be changes. Okay, when radius changes, capacitance will be changes, and capacitance changes means energy will be energy changes. And the last point, decrease in the energy of the system unless q1 r2 equal to q2 r1. So what is the things power will be here? I know q equal to cv. Okay, q equal to cv. So capacitance is depends upon radius. I can say c is directly proportional to r. So question is given, when they are connected to each other, രണ്ട് items, രണ്ട് spheres connected, what will be equal? When two bodies connected, when two bodies connected each other, what will be the same? Potential V is same. Potential same. Potential V is same. Potential same. Potential will not vary. Potential same. രണ്ട് different potentials അല്ലെങ്കിൽ രണ്ട് different batteries എല്ലാം തമ്മിൽ connect ചെയ്താൽ potential same ആയിട്ടുണ്ട്. Okay, so when potentials will be same, I can say V1. Okay, but V1 will be equal to V2. I can say like this one. But in this case, what they have given, there are different charges will be there, different radius will be there. So V1 from this one, V will be equal to how I can write Q by C. C is directly proportional to R. So I'm writing Q1 by R1 equal to Q2 by R2. Here two things will be there. Two things will be there in the sense like, for example, if this is to be equal, okay, if this is to be equal, I need this is to be equal to have this one. What will happen? A system with high energy, should do a transfer to a system with low energy. A system has to do a transfer. High energy le ipo rendu sphere und r1 r2 radius ആണ്. ഏതോ ഒരു സ്ഫിയറിൽ highest energy ഇരുന്നാൽ second sphere ക്ക് അതിന്റെ energy transfer ചെയ്യും. അങ്ങനെ energy transfer ചെയ്യുമ്പോൾ definitely ഈ രണ്ട് system connect ചെയ്യുമ്പോൾ this relation is valid. Okay, this relation is valid, but provided at the same time energy transfer will happen. So based on this one, answer is 4. Decrease in the energy of the system unless q1 r1 q1 r2 ഇതിനെ cross multiply q1 r2 equal to q2 r1. Okay, appo ee oru potential equal agadukku oru definite energy transfer has to occur. Is it clear?
Yes, sir.
Okay,
Yes, sir.
thanks. We'll go to the next question, question number 31. Okay, what is the question number 31 is speaking about? As shown in the figure, oops. 31. As shown in the figure, a very thin sheet of aluminium is placed. Aluminium is placed in between the plates of the condenser. Then the capacity. If they place the capacity, what will happen? Okay, first of all, I know normal in case of a capacitor. Suppose if I have a capacitor, I placed a dielectric between the plates of the parallel plates of the capacitor. Then C dash new capacitance equal to K times of C will happen. So K is actually what? K is a dielectric. That dielectric it will happen. But if it is not a dielectric, then what will happen? This is a dielectric or not? Here it is given like an aluminium Al strip, aluminium strip on. Aluminium strip is a non-dielectric, a non-dielectric. Okay, it is not a dielectric. So as it is not a dielectric, what will happen? Since aluminium is a metal, it's not a conductor. Therefore, the field inside, field means what? Electric field inside will become a zero. Electric field inside a conductor, we have drawn. If this is a conductor, then we have, we know we have already learned a graph. Electric, if we have drawn an X and Y axis over will be here, then we have learned a graph where electric field will be, how it will changes. Inside it is zero, like this, a green color. Then surface electric field will be very high. Then it will be reduces like this. Okay, so electric field inside will be equal to zero. This concept we already learned this one, right, in the theory class. So here, as it is a conductor is placed, so inside the conductor electric field will be equal to zero. There is no electric field effect. If there is a change in electric field, only potential will changes and all other things will be coming to picture. So there is no electric field inside the aluminium. Okay. Hence, this will not affect it. So I know Q equal to CV. Okay, C is equal to what? Q divided by V. Q means it's a charge on these two plates. E plate charge on. So that charge is not changing. Potential is changing. This potential V is changing. V is not changing. V is not changing. Why I am saying like V is not changing? Why I'm saying? Because I know, because what is the reason for that? Because E is zero, electric field is zero on it. Because of what? E is zero again because of aluminium Al strip. Because of aluminium strip, this is going to zero. So aluminium strip place there are no major difference illa aluminium irunnalu ore marida aluminium illennalu ore madita. So there are no changes in the potential. Charge in upper plate lower plate charge. So charge is constant, potential has no impact at all because of the change in the potentials in the because of the aluminium, because aluminium is not giving any electric field inside a conductor will be equal to zero. So there is no electric field. You know the relations between electric field and potentials. What is that? Electric field equal to minus dv by dx. Okay, if electric field is zero inside a conductor, what is potential? Potential will also be equal to zero because potential is not changing. Because potential is a constant. If you take potential is a constant, you know the differentiation of a constant equal to zero. Constant means it is either zero or a number whatever you take. If you differentiate, you will get a zero. Potential is constant means what is the meaning of that one? Potential is not changing because of aluminium. If potential is not changing because of aluminium, then what is constant in these equations? What is constant in these equations? C is constant in the equation, and the question is asking then the capacity. Then the capacity, what will become? Capacity remains unchanged. You got the point? Is it clear to everybody? Again, silence, take it as going ahead. 32, question number 32. A parallel plate capacitor of capacitor C0 is charged by a battery. After charging, the battery is disconnected and a dielectric is filled between the plates of the capacitor. Dielectric place. Dielectric place, now what will happen to the capacitance? The new capacitance C dash will be equal to K times of the initial capacitance. So the capacitance will be increases, very clear. Okay, now we'll look into each of these options. Potential energy of the capacitor. Potential energy of the capacitor. What will happen to the potential energy? Potential energy of the capacitor. PE is potential energy and PD means potential difference. Sorry, we can look into first. I told capacitance increases. So third option will be there. Capacity of capacitor. This third one. This third one, what will match? Third one will be increases. So this will go here. Third one will be increases. Third one increases when how many options will be there? Third peak where two options are. 2 and 4 and random options. Okay, now now we look into the another option. Charge on the capacitor. Charge on the capacitor, what will happen? Charge on the capacitor, what will happen? When capacitance will be increases, charge increase charge decrease. Charge may increases, charge may decrease. The capacitor in between the plates of a capacitor, if I placed a dielectric, what will happen? Capacitance will increases, but charge will not increases. Charge on remains same. 4 will goes to R. Out of the 4 options, we filtered 2 options. Now we'll come to, we have only 1 options will be remains. That is option number 2. Potential energy of the capacitance decreases, and the potential difference of the capacitance will be there. Okay. So option number 2, potential energy decrease, potential difference decrease. Potential energy, potential difference reduce. Potential difference we told, right, in the previous question, V dash will be equal to V by K. Dielectric times potential come here. Potential come here, but definitely the energy will also reduces proportionally. So then 1 Q, 1 Q on 2 Q on both will be potential decrease, potential energy also decreases. Capacitance will what will happen? Increases. Charge on the capacitor, what will happen? It will remain same as like the previous one. Is it clear for everybody?
Yes, sir. So,
Any doubt? So 32 option number 2 is the correct answer. Is it very clear to you, all of you? Hope it is clear, and there are no doubts at the moment, I guess. If any doubts, yeah, please proceed.